A 4,000 kilogram boxcar traveling at 3 meters per second runs into a stationary 3,000 kilogram boxcar, slowing it down to 1 meter per second. What is the velocity of the 3,000 kilogram boxcar, and what kind of collision is this? Well, this is going to be a conservation of momentum problem. We'll assume that during this collision there were no external forces acting on the cars that create some type of net impulse. Certainly there will be weight and there will be normal forces, but they'll cancel each other. So we'll assume that there's no friction on the track. Maybe it's a little simplistic, but pretty traditional problem. All right, just so we understand what's going on here, we're saying that this car is moving along at a velocity of 3 meters per second, whereas this car is not moving at all. So all the momentum is with this car to begin with. As a result of the collision, this car's velocity is now down to 1, and this car's got a velocity that is what we are searching for. So since it's a conservation of momentum problem, it's just a matter of setting up the initial momentums of both cars before the collision and set that equal to the final momentums of both cars after the collision. So this will be 4,000 times 3, and we're going to do positive 3 because we'll take to the right to be positive velocity, plus 3,000 times 0, and then that has to be equal to 4,000 times 1 plus 3,000 times the final velocity. So 12,000 equals 4,000 plus 3,000 VF. 8,000 is 3,000 VF. So VF ends up being 8,000 divided by 3,000, 8/3, or 2.67 meters per second. And notice we have a positive answer, which makes sense because both cars are still going in the positive direction. Now, what kind of collision is this? Well, we know that collisions fall into one of 3 categories: elastic, inelastic, or completely inelastic. Well, we can eliminate completely inelastic because the 2 cars did not stick together. So it comes down to, was this an elastic collision or was this an inelastic collision? And the answer to that is simply based on what happened to the kinetic energy. If there was a loss of kinetic energy in any way because of the collision, then it's an inelastic example. If the kinetic energy before the collision is identical to the kinetic energy after the collision, then it's an elastic collision. So we have to find out the kinetic energy, which is 1/2 mv squared. So prior to the collision, we would have 1/2 times 4,000 times 3 squared. And after the collision, we would have 1/2 times 4,000 times 1 squared plus 1/2 times 3,000 times 2.67 squared. Well, this works out quite nicely to be 18,000 joules, and here we have 2,000 joules plus, alright, so we've got to do 2.2 2/3 squared times 3,000 times 1/2. That works out to be approximately 10,700. And obviously, since we're just trying to answer what kind of collision this was, these two together add up to almost 13,000, which is less than 18,000, so 18,000 being greater, which makes this an inelastic collision because there was a loss of kinetic energy. Obviously, a lot of sound, for example, was probably made when these 2 cars collided. That would be a big reason why energy was lost in this case.